Hello everyone, welcome back to my YouTube channel. In this tutorial, we are going to see a concept of schema evolution. Yeah? So basically, in any data engineering pipeline, nowadays the data engineering part is getting more and more traction. Lots of big organizations are on their journey to move their on-premises system to any of the cloud provider, and lots of things happening within across the industry on this particular subject. So in data engineering, or while setting up these kinds of pipelines where the migrations are going, schema evolution is a very important topic that any data pipeline should consider of. If these are the CSVs getting transferred into some kind of tables on cloud, uh, and if you have some sort of monthly files, daily files, a typical data engineering pipeline, right, where with a certain frequency data lands somewhere, and then there will be some kind of program, maybe a Python application, Java application, any kind of basically a data ingestion framework which picks up that data from the landing location, processes it based on the requirement, and lands it onto the destination storage. It could be anything. If it is GCP, then it could be BigQuery. If it is Azure, then it could be some kind of Azure's SQL system, maybe SQL Server or something like that. Or it could be anything in terms of, if it is Hadoop, then it could be Hive. So destination system could be anything based on the provider. But the concept of schema evolution, reading the data from a particular landing location, putting it into the destination system, these hops of a data engineering pipeline are still remains the same, irrespective of which set of tools, what set of technology, what is the cloud provider. Yeah, using few things here and there may change, but the core concept of a data pipeline will be the same. Right. Now, what is the schema evolution? Basically, schema evolution is a process of maintaining one single version of schema, and if there are any changes at source, if there are any columns that got added, if there are any columns that are not required anymore, like a delete column scenario, then we'll have to maintain that unanimously at the destination system. So let's take an example of it. Yeah. So basically, let's say we are trying to migrate customer data. Yeah. So there are customers, like there is an organization who has some customer base, right? And every day new customers added to the system. Few customers may left, they may deactivate their accounts. New customer keep on coming into the system, and that's the reason, let's say, this particular pipeline, the frequency of this particular pipeline is, let's say, it is daily, right? And let's say every 3 hours, yeah, or every 3 hours we get new set of data. Let's assume that there are some assumptions that we'll have to do to understand the schema evolution. So a schema evolution, let's say customer data, and every 3 hours we get new customer data files as CSVs. Let's say the customer data is coming onto some kind of landing location or a staging location as a CSV. Now the CSV where the customer data is present, it may have multiple columns in that, right? as simple as that. It may have columns like ID, then first name, then last name, and maybe a phone number. Okay, so this column comes into the CSVs. Let's say first few CSVs, let's say first 1000 CSVs has this particular column, and let's say destination system is any database. It could be Hive, it could be BigQuery, anything basically. And what this data pipeline has done is it has created these columns, like first column as ID, then first name, then last name, and phone number. So let's say it has created these many columns in the destination system, and now after few hours the next set of files that we got, let's say it has few more columns added to it. Let's say all these columns are here, and apart from that it has added, let's say, postal address, or yeah, postal address, or let me call it as address. So now in this case of scenarios, the schema evolution feature of a data pipeline will come into the picture. That say now ultimately this particular data, this particular CSV is expected to go get inserted into the same table, same customer table. It's not like since the schema of a customer table has changed, now you start populating the data into some different customer table. No, since we are building a kind of a data pipeline, so destination has to be, obviously same. There is no reason why, if the schema has been changed, it should go to some different table or another version of customer table. No, it is not the right way to do it. So basically this is where the schema evolution feature come into the picture, that your data pipeline should have a capability to identify these kinds of schema changes, right? So before inserting the data into a destination table, there should be a check happening inside your data pipeline that whatever data I'm gonna insert now, does it aligns with the schema of a customer table here. But here, whenever we have these kinds of data sets received from the source, then the answer to this question would be no, it is not aligned. There is a one new column into the data now. And then what your data pipeline should do is it should ideally add this column to the table. It's basically alter schema, your alter table queries, where you can add columns into the existing tables. So you will have to write the logic to alter the schema, add the new column, and whatever number of rows you have already inserted into this particular table up till now, where you are not having the address column, for all those rows or for all those records, the address field should be populated maybe as null or NA. That kind of business decision can be, taken based on any kind of discussion that happened, that how your client wants these fields to be populated. Someone may tell you that, oh, I don't want null values in the address, just replace, if you don't have the address, then replace that with NA. Yeah, or some kind of string that they may provide you, that not applicable, anything. Someone may say you that keep it as null. There is nothing right or wrong in this particular thing. It all depends on what kind of requirement is been given, and you as a developer of data pipeline should add that kind of a logic into your pipeline, and then accordingly populate the values for address field. Going forward, after once now you are basically prepared to insert this new set of data into the table, because now you have made sure that your schema of the new CSVs that are coming is aligned with the schema of your destination table, which is customer table here. So now you can go ahead and add it. Yeah, so basically this is how the schema evolution, one of the use cases of schema evolution, where you need to alter the schema and then populate the values into that. Now one more thing which we generally see here is some of the columns may get populated or some of the column may get deleted. Now for example, let's say phone got removed in few of the CSVs, address is still there, and after that let's say we started getting the email addresses. So this is a postal address and this is the email address. So these kind of changes may happen, that if you see the number of columns, it is still the same, like 5 columns here, 5 columns here. But if you see in further details, that you don't have phone number anymore here in the new set of data, but rather address is still here, and then you started getting one new column as email. There could be permutation and combination of various scenarios, and we'll have to handle those. So here, in case of schema evolution, in case of implementing a schema evolution, what we need to do is we need to obviously add email, but we cannot remove column from your data pipeline or from your destination table, sorry, from your destination table. Since because you stopped or you did not get phone number values in the third set of files that you got from the source, this doesn't mean that you should remove the phone number column. You will have to keep that, because there are some rows that have been previously populated and it has the valid phone numbers, and obviously your business is gonna need those values. So what will happen in this particular case, for all the values where a certain column value is not present, that value may get populated as null, or as we already discussed for the address, your client may give you some specific format in which you will have to populate that values if the actual value is not present. So maybe they may ask you that just populate, if you don't have phone number, then populate that value with some dummy value like 000, 5 times 0, 5 times 9, or 1 2 3 4, or it could be anything, basically like some logic, or keep it as null, anything. Yeah, so this is how the addresses, I mean the values, will get addressed, but we should not remove that column entirely, doesn't make any sense. And obviously, since email is a new column, you again alter this table, add column email, and then start populating the values. For all the values, for all the records where email address is not present, you keep it as null or whatever your client tells you. Yeah? So all these kinds of permutation and combination will have to consider when we are implementing a feature of schema evolution. So typical steps are there when we try to implement the schema evolution. First of all, you start populating, creating the table for the first set of file that you got. Right, as we have seen here, the first version of a table is this id, first name, last name, phone. And then you, whenever you do the ingestion, before doing the actual ingestion, you compare the schema, then add new columns if any. So you'll have to add new columns if any, and then start populating the values. If there are some columns for which you don't have the values, like phone number in the third case, we don't remove that column. So for the missing columns, populate it as nulls or any other business logic that applies. Yeah, so this is what a typical data ingestion schema evolution thing should look like. And here we have tried to explain various scenarios, what happens in certain cases, And these are the frequently seen use cases or corner cases in any data pipeline. So I think if we just remember these two three scenarios, I don't think anything else that will have to add as a feature. But this is what, at a high level, the concept of schema evolution I try to explain, and the typical steps that it consists. Having said that, there are lots of tools readily available which does schema evolution for you, but ultimately the consumption of that schema evolution, I mean, notification that a schema from a source has been changed, is something that a data pipeline, based on the nature of a data pipeline, will change, and you will have to deal with some sort of code change, some kind of code tweak based on the event of schema has been changed. Okay, so this is what the concept of schema evolution, guys. I hope you would have understood this concept. Please let me know in comment section that if you wanted to see the implementation of the schema evolution, with what kind of tools and technology that you are interested in. Based on your comments, I'll try to make the coding details and tutorial for that as well. Thanks again, thanks for watching this tutorial, and I'll see you in the next one. Don't forget to like, share and subscribe to my YouTube channel. Thank you.